Hello everyone. Now this is one of the very interesting topic in GRPC or in general, that is the streaming part. So till now we have talked about how a typical request and response look like in the world of HTTP, or how does it look like in the world of GRPC. So you have a simple request and you have a simple response, and these client or server or two machines, they interact with each other. So how do they look like in case of grpc, or why does even streaming is needed? So let me move on to some of the illustrations I have for you, that the way a typical request and response, how does it look like? So let's say you have a client and you have a server, or you have two machines which interact with each other. And let's say the client makes a request to get 100 records. It's a very common scenario. Get me all the students from ID 1 to 100. Get me students of IDs 1, comma 20, comma 25, and so on. So these are very common scenarios. So let's say a user makes a request to server to get 100 records. Now what will happen? Now the server will process the record number one. They will get data from somewhere, from anywhere, and then they will process it. Then they will go ahead and record the second thing. And then thereafter, eventually, all the 100 records will be processed. And then the server will collate the data. All the 100 records will be collated in one place, and then the client will get the data, all the 100 records, to the from the server, and then it will process. So till now you would have seen the problem. The problems are, the number one is that the client gets blocked for all the 100 requests. So the client made the request, and then it has to wait for all the 100 requests to be processed. And once all the 100 requests are processed, the the client gets the data. So if, let's say, one request takes 1 second, so 100 requests will take 100 seconds. And assuming there is no parallelism and there is no streaming support, or these requests cannot be fetched in batches. And trust me, there will be such scenarios, there are such scenarios where you wouldn't get data in one go. There won't be a SQL query which will get you all the records in one go. There will be cases where you need to make n number of API calls or n number of processings for all those 100 data. So you will wait for 100 seconds to get the data. So a lot of time gets wasted by the client. And then the other problem is around the partial success or failure. So let's say a list of 100 is getting processed, and now say the row number or the record number 25 has some problem. So now this is a case of partial success or partial failure. Now, of course, you can go ahead and handle those cases that, okay, I have two lists, one is of success, the other is of failure, and then I'll return, or I'll have a status as a key, and then I'll return the status to the client, and then the client can decide. But this this gets a little tricky in some cases. So why not just have independent record and let the client process the independent record, and let the server process the independent record? So we can have individual processing units and not at all deal with the list. So that will be the ideal scenario. So this is the traditional request and response, and how grpc handles is quite interesting. That a user makes a request to the server to get 100 records. So server gets the record one, gives it back to the client, and while the client is processing, at the same time the server would start to process the record number 2, and then it will give me the data. And in a lot of scenarios this won't be even sequential. So there will be cases when the server one is processing the server is processing the record 1, and then server is also processing record 2, record 3, and whichever record comes first they will be sent back to the client. So the code becomes very much independent, and a lot of cycles are saved. So for example, now the client is not at all free. So the client made request for 100 records, and the client immediately gets the response for one of the records, and then next seconds it gets the response for other record. So the whole paradigm changes. So now nobody is blocked for anyone, and the the server is just throwing the data to the client, and then the client is just processing the response. So it becomes quite straightforward, and this is how the grpc does. So till now, whatever justification I made around the streaming, it is true for all cases, not just for grpc based streaming, but any kind of streaming which you do. So in case of grpc, you can have streaming in three ways. The first is server side streaming, the second is client side streaming, and the third is bidirectional streaming. And the fourth, of course, where there is no streaming, I have not covered the case. That is when, of course, the request is made from the client, and the client is blocked, and the server gives you the data. So I have not covered that scenario, but there are three cases where the streaming is there. So in the case of server streaming, this is how the definition looks like of the service in the proto file. So RPC means it is RPC. You have a method name, and then this is a request, and this is the response. So this is the streaming response. So you can imagine this with the frame of reference of a server. So when I write these methods, so these methods must be implemented in the server side. So if a client is making a request to a server to get the data, so a server will have a method named stream from server with a parameter as request and the response as a stream response, which in this case in Java it is observable. So that's a data type that they use. So this is how the function definition will look like at the server side. The same goes here. This is how the function definition will look like in the server. So if you write any definition in the proto file, so the server is bound to implement this method if they want to use this facility of grpc streaming. So you implement the method in your java file in the implementation of the service, and here again it's a single response and the stream of requests, and this one is the bidirectional request and response. So you can imagine the first one can be around the case you upload some data, and the second one is when yeah, so the first one is when you download some data, the second is when you upload some data, and the third is you communicate, you have a reactive programming in both client and server. So now, without much ado, we'll jump onto the coding. In the previous lecture, we have already seen the most simple implementation of gRPC. Now, in this one, we'll just build on top of it. So we already had a simple implementation of a simple method. Now we'll just add these three methods in the particular video, and then we'll just proceed from there.